Today we are going to be looking at the complex plane, which is a two-dimensional plane for graphing complex numbers. But before we do that, it's going to be a really quick lesson. I want you guys to do now. So do number 1, simplify that expression into a plus bi form. Has to be an a plus bi form. And also graph these 4 points on the xy coordinate below. Pause the video, take 5 to 7 minutes, and complete this and play it once you're done. So when I look at the first expression, the only expression actually, I want to add these two numbers together, but look at our denominators. We do not have common denominators. So we have to get common denominators. So before we go about doing that, I'm going to simplify each fraction first. So the first one, 1 minus I over 2 plus I. I'm just going to write that one off to the side. So that is going to be 1 minus I over 2 plus I. I can't have an imaginary number in the denominator, so I have to multiply by the complex conjugate of the denominator, which is 2 minus I. So I multiply the numerator and denominator by that. I double distribute on the top. I get 2 minus I minus 2I plus I squared all over 4 minus 2I plus 2I minus I squared. All right, so combine like terms and substitute in for I squared. You would get 2 minus 3I. I squared is -1, so it'll be -1 all over 4. The 2 i's cancel out. We'll have 4 minus -1, which would simplify to 1 minus 3i all over 4 minus a -1, keep change, 5. So we simplified that first fraction, excuse me. Now let's simplify that second fraction. So that would be 1 plus I over 1 minus 2I. Same thing, multiply by the complex conjugate. We change it from subtraction to addition of the denominator and double distribute. So the numerator would be 1 plus 2I plus I plus 2I squared all over 1 plus 2I minus 2I minus 4I squared. Combine like terms, substitute in for I squared. So you would have 1 plus 3I plus 2 times -1 all over, the 2 i's cancel out, 2i minus 2i is 0, 1 minus 4 times -1. Further simplify, on the top you would have 1 minus 2 to combine like terms, so you would have -1 plus 3i all over -4 times -1 would be +4, so 1 plus 4, which is 5. Oh, look at that. We have common denominators, so I can just add these two now. That was nice. So 1 minus 3i over 5 was our first fraction. Our second fraction was, we simplified to -1 plus 3i all over 5. I'm going to write that under one fraction since we have a common denominator, so that would be 1 minus 3i plus a -1 plus 3i all over 5. So 1 minus 1 is 0, -3i plus 3i is 0, so we're left with just 0 on the top, 0 over 5, which is just 0. That's it. Wasn't expecting it to be 0. So yeah, that's what it simplifies to, is just 0. And graphing each of the following points. You guys have been graphing for a while now. So there's a reason we're doing this. You're going to see in a second. So its first graph 0, 5. That would be here. -1 in the x, 7 in the y would be here. Make sure you label the point. C, -5, -9 would be here. And D, 7, 0 would be here. You're going to see on the next page that graphing in the xy plane, xy, is very similar to graphing in the complex plane. So let's go to the next page. On the next page, what should I be able to do by the end of the day? I can graph complex numbers on a complex plane. That's it. We're just graphing complex numbers. So here's the complex plane. Take a minute and look at it. I want you guys to fill out this question. What do you notice is different about the complex plane than a coordinate? Think, when you hear coordinate plane, that's the XY plane. So think about that. Pause the video. Think about it for a minute or two. Fill something in and play the video once you're done. So it's still two-dimensional. There's a R and there's an I. What do you think the R stands for? That stands for the real part. What do you think the I stands for? That stands for the imaginary part. The only thing different about this is instead of the x-axis, we now have the r-axis. So the x-axis is now the r-axis for real. So you graph the real part, and I'll show you what I mean in a second, on the horizontal axis. And look at the y-axis. The y-axis is now the imaginary, the I-axis for imaginary. That's the only thing that's different. So I'm going to graph Z1 and Z2, and I want you guys to graph the next three. So looking down here, Z1 is 1 plus 5i. The real part of this is the 1, A. And the imaginary part of this is the B, 5. So you would, on the graph, you would go to 1 in the R, the real, which is the horizontal axis, and 5 in the Y, or excuse me, the I, which is the vertical axis, and that's our point right there. Make sure you label it. That would be Z1 with a subscript 1. And let's do Z2. So Z2, same thing. The real part is the -2, so we go -2 in the real axis. And imaginary part is the +3. So we go to +3, or +3 in the imaginary axis. So -2 in the horizontal, or the R, and then +3 in the vertical I. And make sure you label that point Z2. I want you guys to take a minute and just do Z3, Z4, and Z5. Pause the video and play it once you're done. So Z3 is 4 minus 9i. So you go to 4 in the reals and minus 9 in the imaginary. It's going to be all the way down there. Z3. Z4, -7 in the reals. And then -1i, or -I would be right there. That would be Z to the 4th. Or sorry, Z4. And Z5, there's no real part. So that is 0. And the imaginary part is 10. So we go up to just 0 in the real, 10 in the imaginary. And that would be Z5. That's it. It's very similar to graphing. If you're thinking, holy cow, that's all I got to do? That's all you got to do. So that's graphing the complex plane. I would do the success criteria and the classwork, and that's it.